Okay, so in this video what we're doing is solving quadratic equations by completing the square. Sometimes factoring will work, sometimes it won't. You'll find out that when you factor you get prime, so if that happens you want to try to complete the square. Now as always, if the algebra is too hard for you, you can always solve by graphing, so just keep that in mind. Alright, so I'm going to do the first problem in red. And what I have is a trinomial. I might try to solve this by factoring, but the instructions say to solve by completing the square. Remember, when we solve it by completing the square, the very first thing we want to do is get x squared plus bx by itself. So when I do that, I find that I have x squared plus 10x equals 3. All I did was take this minus 3 and add 3 to both sides. Well, now based on this, my b is equal to 10. The next step says, alright, well, we want to take b, whatever that is, for this particular problem is 10, we want to divide it by 2. So 10 divided by 2 is 5. And I'm going to put a star next to this because if you remember, like we did in the completing the square videos, this step 3 is going to help us factor this in the very end. Okay, so now that we found what b divided by 2 was in this particular video, it's equal to 5. We're going to take this number and square it. So we have 5 squared, which is 25. Remember, we take this 25 and we're going to add it to both sides of our equation now. So plus 25 plus 25. What we have now created is a perfect square trinomial that can be factored into the square of a binomial. So we're going to use our factoring pattern to get that square of a binomial. It's x plus b divided by 2 squared. If you remember, in this problem, b divided by 2 was equal to 5. We found that in step 3. So this perfect square trinomial can be factored into x plus 5 quantity squared. So my problem now becomes x plus 5 quantity squared equals 28. Okay? So what this means now is I can now start solving. Well, I have a square. I want to get rid of that square. So to do that, I need to square root. But remember, if your power is even, for instance here it's a 2, you need to consider plus or minus. It's going to be 2 answers. So square, square, plus or minus. So we have x plus 5 equals plus or minus the square root of 28. Okay? So now we need to get x by itself, so we have x equals negative 5 plus or minus the square root of 28. You can leave your answer like this. This is perfectly acceptable. However, you might want to get your answer just as a decimal. So before you do that, you probably should split this up into 2 separate problems of x. I'm going to call it x1, so my very first answer is equal to negative 5 plus square root of 28. And my second answer, x2, is going to be negative 5 minus the square root of 28. Notice it's not x squared. The 2 is down in the basement, so just keep that in mind. Now I'm going to use my calculator to turn each of these into a decimal. So I go into negative 5 plus square root of 28. And I get 0.29. Okay. Now, if I go in here, negative 5 minus square root 28, I get negative 10.29. Okay. Now, what I want to do is I want to verify that I do have 2 answers. So I'm going to go back to the original problem and graph this real quick. y1 on the left, y2 on the right. So on the left I had x squared plus 10x minus 3. On the right hand side I had 0. So I want to hit graph, and I want to hit zoom 6 every time I do a new picture. And I can tell that there's going to be one answer here and there's going to be another answer over here on the left, but I can't quite see it, so I'm going to zoom out one time. Now I see that there's in fact 2 answers. So second calc, option 5, First curve enter, second curve enter. I'm going to find the answer on the left first. Negative 10.29, which is exactly what we just found. If I scroll down a little bit, negative 10.29 right there. So that's good. And then find the other answer, second calc, option 5. First curve enter, second curve enter. I'm going to find the answer on the right, so move your cursor over. 0.29. So again, if the algebra is too hard for you, especially completing the square, a lot of people struggle with that, use graphing. And you can see by doing the graphing method, I was able to do all this work that took me about 5 minutes. I was able to do it in about maybe 2 minutes tops. What I suggest you do now is go back over this problem, get down all the scratch work, make sure you understand it, then hit pause. When you come back from hitting pause, all this scratch work is going to be gone. I'm going to do the next problem in green. Okay? So let me get rid of my scratch work. Okay, so in the second problem, I'm going to do it in green. Our very first objective is to get x squared plus bx by itself. Okay, so my very first step, I need to get rid of this constant, so minus 12 on each side. So I have 3x squared minus 6x equals negative 12. Now, I want x squared plus bx. Notice there's nothing in front of my x squared here. So I need to get rid of this 3. So I'm going to divide by 3 both sides to everything. It's very important that everything gets divided by 3. So I have x squared minus 2x equals negative 4. Now I finally have x squared plus bx by itself. So x squared minus 2x follows that pattern. So based on that, b is now going to be negative 2 for this particular problem. Once we know what b is, we're going to divide that by 2. So for this particular problem, we have negative 2 divided by 2, which is negative 1. I want to put a star next to it because that's going to help me factor in the end, which I'm going to need to do. Now that I know that b divided by 2 is negative 1 for this problem, I'm going to take that number and square it. So b divided by 2 squared, and negative 1 squared, which is positive 1. Once we've squared that number that we just found, we're going to add it to both sides of the equation. So I have plus 1 plus 1. Now I have a perfect square trinomial that can be factored into the square of a binomial using the factoring pattern x plus b divided by 2 squared. Well, I know in this particular problem we found that b divided by 2 was negative 1, so my factoring pattern becomes x minus 1 squared. So this becomes x minus 1 squared equals negative 3. Okay? So now what I want to do is to actually solve this equation. The very first thing I need to do is to get rid of the power. Okay, so again, my power is even, it's 2, so that means I'm going to square root each side. But since I'm square rooting, I need to consider plus or minus. Okay? Now, square and square root are going to cancel out, so I have x minus 1 equals plus or minus the square root of negative 3. Now, before I do anything else, I need to realize, hey, anytime I see the square root of a negative number, I can think of that as x minus 1 equals plus or minus the square root of negative 1 times 3. Now, if you go back to chapter 2, remember I can split this up into 2 separate parts. So x minus 1 equals plus or minus the square root of negative 1 times the square root of 3. And what we talked about at the end of chapter 2 was that the square root of negative 1 is the same thing as saying I. So x minus 1 equals plus or minus I square root of 3. Now we're ready to keep going. What this automatically tells us, as soon as we see an I, that means graphically there's going to be no real solutions. However, algebraically there are 2 complex solutions. So that's the only downside about graphing. It works 95% of the time. However, if you end up with complex solutions, aka you see an I, that means it's not going to show up graphically. Just our calculators aren't smart enough to do that, unfortunately. So I want to keep going with this problem. So x plus 1 equals, sorry, I had a brain fart there. What I'm doing is setting plus 1 to each side. Okay, I'm just going to combine like terms where I can. So x equals 1 plus or minus I times the square root of 3. And I could leave my final answer like this. I have x by itself, so that's totally okay. Or if you want to, you can split it up into two separate equations. So my first answer is 1 plus I square root of 3. My second answer is 1 minus I square root of 3. Now, let's go back to the original problem, and I want to graph it. And again, since we had complex solution, meaning we see to I, we're not going to be able to solve this by graphing. So, I want to show you what that looks like. Alright, so I'm going to go to y equals, again, the left side which of the original problem just goes in y1, so 3x squared minus 6x plus 12. y2 is still 0, so I'm going to keep that the same, and every time I do a new picture, I'm going to hit zoom 6. What we're doing is, since y2 is 0, we're trying to, here's the little piece of my parabola, y1, here's y2. We're looking for a point of intersection. Obviously, there is no point of intersection on the graph, so graphically, there's no real solution. However, there is a complex solution, and that's what we had to find algebraically. X equals 1 plus or minus I square root of 3. So, if you see something like this, where there's no point of intersection at all, that means you have a complex solution with an I in it that you have to do by hand. So let me say that again. If you try to solve by graphing and there's no points of intersection, there's always going to be algebra work that you can do to get complex solution with the I. So if you see this, that means you need to give up on the graphing and try to do it by hand. Okay? If you have any questions, let me know. I'm happy to help you.